Okay, fine. Thank you. So, please share the presentation in full screen, Ayush. Thank you. So, again, the content includes the function and purpose of P&ID, difference between Ayush, please go to content. Yeah, thank you. Difference between BFD, PFD, and P&ID. Limitations of P&ID. P&ID is a piping and instrumentation diagram. The P&ID support documents and information. P&ID symbols and notations, how to prepare them and read them. So in general, by end of this lecture, at least you will be able to understand what is P&ID, what is PFD, what is BFD, what is the importance, how we can prepare the P&ID, which one is the best guideline to follow for the P&ID, and what is the purpose, objective of P&ID in and use of P&ID in chemical industry during project stage, during construction stage, and during the operation stage. Fine. So please go to next slide. Uh, Next one, please. So we'll start. We are starting with the introduction about the P&ID. Uh, so P&ID basically, as I said, that it's a piping and instrumentation diagram, shows the piping and related components of a physical process flow. It's the most commonly used in engineering field. So P&ID shows all of the piping, including the physical sequence of branches, reducers, valves, equipments, instrumentations, and control interlocks. Actually, in general, we say that this is the language for the chemical engineers to represent the our process flow, including instrumentation, including equipments which are involved in that particular process, and some basic informations with details and notes of the drawings or notes of the designing part, which are the important to understand the process. So you can see from the pictorial diagram that uh, uh, transfer pump is shown by tagging PT201. We have one uh, instrument that is operated through air, the pneumatically operated instrument, one FT shown, then mixer and the reactor. So it's a sequence by pumping and controlling through the pneumatically operated valve. Material is transferred to the mixer through the flow transmitter, which is indicating or maybe recording and maybe controlling the flow of the stream. So this is how P&ID can be represented. Next slide, please. Ayush. So what is P&ID? So P&ID is a tool for detailed engineering and commissioning. So it includes detailed engineering, means it's a designing, normally design in the basically two parts. One is a basic designing. Normally we say it's a front end engineering design, and from basic design we do a detail engineering, which includes layout also of the piping, detailed calculation of flow, mass balance, energy balance, all these things. So basically P&ID is a tool for detailed engineering and commissioning schematic of process plant. So schematic means uh, flow of material from starting from raw material till finished product, includes the instrumentations, also includes the various equipment details, capacity of the equipments, parameters of the equipments. So like that, it's a scheme of the process plant. And in general, as I said, that a communication tool, a basis tennis. And this is also helpful when we will have any troubles in the plants, or to troubleshoot the plant. We refer normally the P&ID, material balance, energy balance. So this is the one of the important element during the troubleshooting also. A graphical table content of the other engineering documents. Please go to next. So basically, this is the introduction about the P&ID. Now, function and purpose of P&ID. What is the function and purpose? So P&IDs are foundationals to the maintenance and modification of the process that it graphically represents. So that is basically maintenance and modification during the operations that normally we do. We after commissioning, suppose we want to increase the batch capacity or we want to and in the overall capacity of the plant, or we want to change some one or two equipments in the plant, so we call it as a modification of the process. So during the modification also, this is useful. P&ID is useful because it's a language, so we have to take the reference whenever when we do some modifications. So we take this as a reference and we first decide the changes in the process or equipments and plants, and then we mark it on the P&ID, we do the changes. So there is a complete sequence of modification. So P&ID plays very important role in modifications also, like in the operation, similarly in the modification. Next please. During the design also, P&ID is very important because through the P&ID we do all the risk assessments, and basically the sequence or chronology we can say in the project is like that. First we start with the concept development, then selection of one process out of many options, then we do the basic design of the process, and after basic design, after detailed design, during the before commissioning, installation also, we have different risk assessments. So in all the risk assessment, basically P&ID is a basic requirement. Through the P&ID, the risk assessor can understand the process, can find out the different uh, details of the process, and they do the risk assessment. So in general, P&ID is a basic tool also for the all the risk assessments. So after the risk assessments, normally if there are some recommendations for changes in the process or instrumentations or logics, interlocks, or some designs, so uh, engineers involved in the design, they do the changes and they then finalize the drawing. So this is the actually chronology for the any project. So function and purpose of P&ID. For processing facilities, it's a graphical representation of key piping and instrumentation details. So you can see from this P&ID, Ayush, please zoom in so that easy to see it. So from the P&ID, you can see if you start from the left side. So let us take one only example, one part of this P&ID to understand the P&ID. So if you see there is a one pump on the left side, tag number of pump is PU4502. So in the pump, you can see there are few rounds, circles and squares are there. These are all the legends for the instrumentation. So in the P&ID, important thing is legends. Through legend, we can represent the equipments, we can represent the instrumentations, we can represent some logics also. So there are different use for different legends, and standard legends are available in the guideline, which I will share you in detail in the later on. So you can see the pump with some legends, instrumentation legends. Circle means round means the instrumentation tag, square means further extension of that logics of that instrumentation. Then from pump you can see a pipeline piping connected to strainer. From strainer it is again going to one expansion tank. In between expansion tank you will find lot of instrumentations related to pressure, flow, along with the control valve. I think before the expansion tank there is a one tank also. In between safety valve is also there. So through this legends we explain the process in the P&ID. It's a mainly flow along with instrumentation, so we call it as a piping and instrumentation diagram. Next slide please. So understanding P&ID is very useful if you are in project team, if you are in maintenance team, if you are in operation team, or you are in designing or troubleshooting team. So if you are involved in any chemical process, so understanding of P&ID is a basic thing. So function and purpose of P&ID. So what are P&ID is all about? So as just we discussed that P&ID evaluate the construction process. So in construction, a lot of activities are involved. So like if you want to make a foundation of the pump, so that is through the P&ID help us in defining these things. So what should be the distance, how, what will be the piping requirements. So second point is basic for control programming, develop guidelines and standards for facility operation. So through P&ID, we prepare a standard operating procedure. So that is the basic document for preparing the standard operating procedure. So before the commissioning, so after installation, normally we do the commissioning and then it goes to operation phase, any project. So before the commissioning, we should have standard operating procedures or guidelines which help every operation team to understand the procedure and follow the procedure in same manner. So for developing these guidelines and procedures, also P&ID is a basic element of basic document. Provide a common language for discussing plant operations. So again, it's a language, as I told you that it's a language. So this will help you, this will help the operation team in discussing and understanding the projects, giving the trainings to the operation team for the process. So this is the basic language we can say for the uh, any process plant. Create and implement philosophies for safety and control, of course. So basically, so when we give the when we provide any instrumentation in the process, so there are basic two objectives. Either this is for process control or this is for safety purpose. So in both case, P&ID give the basic guideline. P&ID gives the basic guidelines. So what should be the process? So process controls, in defining the process control also P&ID is helpful, and in defining the uh, safety features or the requirement of the safety of the process also P&ID is very useful. So through this P&ID we give first the
Hello, sir. You have muted yourself. Can you
oh
unmute?
sorry
Yes,
oh
it's
sure,
okay.
this is
Now,
recent one, is I think it's
yes.
automatic. So this
I
is
don't.
recent one, eh?
Yeah, recent one. Just
Fine, maybe because this maybe
yes.
some reason. Okay, sorry for that, thank you for
No, it's all right, sir.
Uh, so again, just re-repeat about the P&ID. So P&ID helps us in evaluating the construction process, basis for control programming, develop guidelines and standards for facility operation. So with the P&ID operation, we can give the training to operation people also. And normally during the process of project, we have designing, then installation, commissioning, and then operation. So before commissioning, commissioning team and operation team should have the process details, SOP and guidelines. So guidelines and SOPs and standard operating procedure, sorry, operational procedure and guidelines that normally we develop with the help of the P&ID. So this way P&ID is helpful to us even in developing the controls and logics. Normally controls and logics requirement and for the two different objectives. First is basically for process control. Second part is for the safety purpose. In both cases, we develop this logics through with the help of the P&IDs only. Create and implement philosophy of safety and control. Design a conceptual layout of the plant. That is also through the P&IDs only. Form recommendation for cost estimate, equipment design, and piping design. Because P&ID gives all details about all the equipments, so this is helpful in developing the costing also. Next one, please. So in general, P&ID gives us all details, basic informations about the process. Of course, there are a lot of other documents in the process safety informations or designing of the process. But key to all is P&ID. So P&ID is used for field of instrumentation control or automations also. So that is why it is called P&ID, process of piping and instrumentation diagram. So it is used to maintain plant safety as a reference for process safety information also. So again, in process safety information, there are numbers of informations required, but first information we need is piping and instrumentation diagram. If something does go wrong, so again useful in troubleshooting also. Next slide please. So in general, what why we call it as a language for chemical engineering for the process. This is the basic reason why P&ID is called a language for chemical engineers for defining the process. So now, actually, there are three terminology we use for defining the process: BFD, PFD, and P&ID. Much related with each other. So let us see one by one what is BFD, what is PFD, and P&ID. Next slide, please. So basically, block flow diagram. BFD is a block flow diagram. So diagram is self-explanatory. You can see, or you might have used in your education many times this BFD. BFD normally we can use for any explanation of any process, not chemical process, but any management process. It can be HR process, it can be a financial process. So normally we use block and lines with the directions to define even our organogram. For defining organogram also we use the BFD. It's a simple basically. So we use the block, we give the arrow through input and outputs. So in here example you can see there is a one reactor uh, where the raw material is hydrogen and toluene, and output is a product and effluent, so which goes to gas separator. From there it goes top uh, output is mixed gas, bottom output is a mixed liquid which still again goes to still their benzene separate and toluene recycle, again going back to reactor. So this is the way we can explain. So here you will find only uh, raw material input and output flow, and extension of this block flow diagram can be used for material balance also. So here you will not find any detail about equipment, process controls, instrumentation, all these things. In block flow diagram, you will have input and output, and further extension can be a material balance. So this is the basically block flow diagram is a drawing of a chemical process used to simplify and understand the basic structure of the system. Blocks are connected by straight lines represent process flow streams. Next slide, please. So you can now you can understand what is the block flow diagram, and you can recall that you have used this block flow diagram many times. Now, extension of block flow diagram is a process flow diagram. So here you can see this process that one centrifugal pump is shown for transferring the crude oil, then pass through cold preheat train. So exchangers are shown through as a legend. So two exchangers are there, which is again going to the desalter through a emulsifying device, and from desalter output, top output is to crude furnace through the heat exchanger again, and bottom output is going to shell and tube heat exchanger, from there to pump suction, which is wash water pump, and again one stream is going back to this pump, centrifugal pump suction, and there is a one more pump for the mud. So through this process flow diagram, we can represent the flow along with equipment. So we here in process flow diagram, you will find process flow along with equipment. Different from block flow diagram. In block flow, you had a block only. So instead of block here, you will find the various equipments which are used. Otherwise, everything is same, input, output, everything, but that is through equipments only. So this is process flow diagram. So block flow diagram you can use anywhere in any of the management function, can be in HR, can be in finance also, but process flow diagram specifically for chemical process only. So that is the basic difference. Again here only equipment, no instrumentation. Next slide please. So now you can find easily if you will go to P&ID, or you can recount the P&ID which was shared with you. So in P&ID it's a piping and instrumentation diagram. So first block flow diagram, second process flow diagram. Process flow is specifically for chemical process, but only equipments, no instrumentation. So you can find the difference here in piping and instrumentation diagram or P&ID. Here equipments with proper legends, instrumentations are also there, and if you will see real P&ID, which we will share you later on, so there are a lot of other informations like legends are also there, like keynotes are also there, capacity of equipments, parameters of equipments, sometime material balance is also there. So you can put as many information as you want is important on the P&ID diagrams. So it shows the interconnection of process equipment and the instrumentation used to control the process. So that is the basic difference between block flow, process flow, and piping and instrumentation diagrams. All are normally used, but final design and drawings mainly we use the P&ID for all the explanation. Normally we can say, see, chronology is like that. First we prepare the block flow diagram. From block flow diagram we prepare the process flow diagram. So in the process flow diagram we define the equipment's requirement, and capacity of course also can be defined in the process flow diagram. And from process flow diagram we prepare the P&ID. So in P&ID we involve the various instrumentations. We include the instrumentations. So again, instrumentations two type, for process control and for safety purpose. So this is the sequence or chronology for using the various diagrams. So difference between PFD and P&ID is already explained. So P&ID is a piping and instrumentation diagram you can see from the picture, and PFD is process flow diagram. So you can very easily find the difference. And in P&ID there are instrumentation are there, and PFD no instrumentations. Next slide, please. So basically this is a basic about the P&ID, but P&ID also has some limitations. So everywhere you find that some advantage, some limitations. So of course P&ID also has some limitations. So first limitation, it's a we can say it's a 2D diagram only, no 3D. But in many analysis we need a 3D diagrams also. So that is a different thing. We do a 3D modeling for 3D diagrams. But first limitation is a 2D diagram. So they can't be relied as they aren't necessarily drawn to the scale or geometrically accurate. So here, say for piping, we don't use the scale, or we don't use the actual length of piping here. We just represent that we are connecting two equipment with the piping, or we can have the size of the piping, and MOC also, various other like insulation is provided or not provided, purpose of, or we can say piping used for with different fluids, so fluid name also. So that can be there, but we can't have this actual length of the piping in the P&ID, actual size of the equipments. So there is only one accepted universal standard for P&ID. Normally there is a one standard throughout the world that I will share you later on. Number, name also, and important legends in the P&ID that diagram. But that is the base document. From that document, every company prepare their own legend sheets or guidelines for preparing the P&ID. So if you go to good corporate companies, so you will find their own guidelines for P&ID preparations, their own legends. So they share all these legends and mainly basic informations of P&ID with all the project documents. So you will find, when you will see any company's project documents, so you will find the legend sheet first. So that's why it is important to design and review the documentation that gets down to the real nuts and bolts of the support documents. So this is all the limitation of the P&ID, but uh, very few limitations like 2D diagram, not to this scale. Other than there's a lot of advantage of P&ID. So that is why it is called as a language for chemical engineers. Next one, please. You just note down your questions. So we will keep 5 to 10 minutes in end of the session for this question and answer. So till that, you please note down your all the questions. Definitely we will have question answer sessions. P&ID support documents and information. So what documents we need to prepare the P&ID, and what are the informations we have. So please go to next slide. So you will find how uh, what are the informations we require. So first information we require for P&ID is process flow diagram. So from block flow we prepare a process flow diagram, and from process flow diagram we prepare a P&ID. So first document we require for P&ID is a process flow diagram. Next one please. So PFD, already you have seen that what is the PFD. So again you can find it here. Then piping material specification, of course we need in P&ID is a piping material specification. So what normally we have in the piping material specification, so you can find in the piping material specification MOC of the piping, pressure rating of the piping, utility for which chemical it is used, it will be used, or of course insulated or not insulated, use purpose, using for hot or cold purpose. All these informations we should provide in the P&ID, and for that we need a specification of that particular piping material. Next one please. Similarly, equipment detail information like capacity, temperature, pressure, other ratings also can be. So equipment and instrumentation specifications. So in equipment normally MOC, capacity of equipment, temperature, pressure rating, all this we normally provide. So basically after deciding first we prepare a block flow diagram, then we prepare a process flow diagram. So in process flow diagram, when we decide the equipment, so we prepare a equipment specification sheet, or similarly when we finalize the instrumentation, so we prepare a instrumentation specification sheet. So from that sheet we get the information for the equipment and instrumentation specifications, and then normally we keep information about equipment and instrumentation specification in P&ID based on the company's corporate guidelines for the P&ID preparation. So you can see here the sheets, this like a pressure transmitter, so data sheet, so which have everything MOC and many more informations. So these are the specifications. Normally initially we prepare a very simple specification sheet, but after detailed design we make a complete specification sheet for ordering the equipment or instrumentation. Next slide please. Of course, other than equipment and instrumentation specifications, we also required functional requirement specifications. It includes the functional description, communication and scope definition of the process. So that is related to process. Like we have seen that in equipment we are charging 12 in some other gases. So that specification normally we put a flow also or material balance also sometime in the P&ID, uh, some specific parameter of the particular chemicals, that also we can mention through the P&IDs. So all that is includes the functional description like process flow and and scope of the definition of the process. So that we can define through the P&ID. Next slide please. So P&ID, what we should include in the P&ID? So that is the important thing. So there are some basic minimum requirement for P&ID. Other than that, any company can define their own requirements also. So, but we should at least know what basic we should have in the P&ID. So instrumentations, of course. So whenever there is an instrumentation, so there are interlocks, logics, controls also we define through the P&IDs. Mechanical equipment with names and numbers. So in any instrument or any equipment, tag number is very important. So that also we mention in the P&ID. So uh, tagging of all the equipment and instrumentation, that is done when we prepare the P&IDs, or PFD, when we prepare PFD where we give the tagging of the equipments. All valves and their identifications, of course. So there are a lot of type of valves we are using in the industry, a lot of type of different types of pumps we are using in the industry. So we are using different legends for different type of pumps, different type of valves. So that we represent and that we give in the P&ID. Will give you a clear picture about the type of pump, type of instrumentations. Process piping size and identification. Of course, when we give details of any piping, so size of a pipe also we mention in the P&ID. Miscellaneous things we give in the P&ID like vents, drains, special fittings, sampling lines, reducers, increasers, lot of things we can represent in the P&ID. So for each and everything we have to define the legends. Their standard legends are also there. Otherwise we can use company defined legends also. So through these legends we can give lot of information in P&ID. Permanent startup and flush lines. Yeah, that sometimes suppose there are some temporary arrangements also there in the P&ID process. So that also we can mention through the P&ID. So this particular line is for startup, for flushing, for draining. Equipment rating or capacity, of course, that is the basic requirement. Next slide, please. Even like suppose we are using the pump, so we can give the details of pump motor also through the P&ID. Flow directions, of course, we can provide the flow directions through the P&ID. Interconnection references, like there are some tie-in points are there, so connecting one plant with the another plant for particular chemical, so that also tie-in details also we can provide through the P&IDs. Control inputs and outputs interlocks, so like in instrumentations or controls also, type of instruments through the legends. It's a pneumatically operated, air operated, or electronic signals are there, so everything we can represent through the lines or dot. Sometimes lines, mainly pipelines or piping are used with the permanent lines or full lines. Dotted lines are used for interlocks. Similarly, instrument pipings are also have different legends. So control and input details, all the details starting from sensing device to transmitter to interlocks, logics, everything can be defined through the P&ID in the P&ID process. Initiation inputs also, of course, we can provide through the P&IDs. Computer control system inputs, different computer like right nowadays we are using control complete control systems like a SCADA system or different system. You will find a different name, like SCADA is one of the trade name of company. They are providing the control systems. There we have like our computer is operating the systems. So that also can be defined through P&IDs. Vendor and control interfaces. Vendor and control interfaces also. Suppose few packages directly vendor is providing to company, like a compressor. So compressor, a vendor complete package he provides to company. So the complete interface of vendor package for the compressor and input to the company where they will connect, that also can be provided through the P&ID. So I think here I just want to add one more thing, that like P&ID, which is we are using for the process, we also have a line diagram. So just you don't get confused between piping diagram and line diagram. I just want to make some clarification here. Basically, piping diagram P&ID is used for chemical process. Similarly, for all the electrical cable details or panel details, we are using the line diagram. So that is normally related to electrical function. So line diagrams, we normally have the informations of cabling plus all other related informations for the electrical system we can find in the line diagram. So line diagram differs from piping and instrumentation diagram with respect to utility. Line diagram is for electrical system, piping and instrumentation diagram is for chemical process. Next one is intended physical sequence of the equipment. So that is very important to show the flow. So like that is can be used. Instrument root valves. So instrument also, in instrumentation also we have different control valves. On off valve, some on off valve means full open, full close valve, or sometimes control valves to control the process, safety valves, pressure regulating valves. So all different valves can be shown through the different legends. Control relays, manual switch, primary instrumentation tubing and valves. So primary instrumentation tubing, which we are using to either provide the pneumatic pressure or to transmit the receptor to a controlling device. So pressure, temperature and flow data also, that is important. Mainly in P&ID, normally we give pressure and temperature data only. Other data, if really very important, then we give in the P&ID. Otherwise, that is available in the design basis. So design basis is also one of the document. So normally, again, if we refresh the chronology which I discussed earlier, we start with block flow diagram. So before block flow diagram, we prepare a design basis. So sequence is like that: preparation of design basis, then block flow diagram, process flow, and P&ID. So basically pressure, temperature and flow data, elbow, tees and similar standard fittings. Yeah, important fittings also we show through the P&ID. So any explanation if we require which is important either for quality or optimization of process or safety related, that also we can mention in the P&ID. So extensive explanatory notes, through this we can mention these informations, important informations. Next slide please. So basically these are the basic informations we need, and through these informations we can prepare the P&ID. So now important thing is legends and symbols and notations of the P&IDs. So that we will see what are the symbols and notations in the P&IDs. So basically P&ID symbol and notations, one area of P&ID that is standardized are the instrumentation symbols. So you can see the guideline ANSI, it's an international guideline, ISA S5.1-1984 R 1992, that is American National Standards ANSI, instrumentation symbols and identification. This is the guideline normally available throughout the universe for preparation of the P&ID. Other than that, there is I think no Indian standard available for P&ID. So we all refer this. Through this reference, companies prepare their own legend sheets, guidelines for P&ID preparation. So instrumentation symbols appearing on diagram adheres to ANSI ISA, that is 5.1-1984 standard. So whatever you will find later on this presentation, this is based on this guideline. So you can also refer this guideline, readily available in the soft copies also, just to understand details also. So many companies like our company also, when we do the interviews also, so one of the our part of the interview is this understanding, just we are try to check the understanding of the candidate about the P&ID. So we give the P&ID to them to just understand. We give the time 1 to 2 hours in our office, and then we ask the question. So because basic reason is, if you know the P&ID, then only you can understand the process. Next slide please. So if any of the students wants to go for designing industries, like designing projects industries, project of department, or designing or risk assessment or troubleshooting, so they should have the basic knowledge of P&ID. Then only they can understand other documents for their departments, and they can participate in their roles. So starting with the legends of equipment. So equipment is comprised of miscellaneous P&ID units that do not fit into the other categories. This group includes hardware like compressors, conveyors, motors, turbines, vacuums, and other mechanical devices. So Ayush, please zoom in so just it is little bit clear. So you can see lifting, conveying, and transporting equipments. Yeah, thank you. So here you will find single stage reciprocating compressor, dual stage reciprocating compressor, rotary screw compressor, different type of compressor, motor driven fan, motor driven axial compressor, turbo generator, so turbo compressor. So all this you will find in the equipment section of this standard. Similarly, you can find the trails also. So please go to next slide. These are the various examples of the P&ID legends. So equipments which includes the compressor, like rotary compressor, motor, through step motor, DC motor, again liquid AC motors, gears, centrifugal uh, centrifugal fans, different centrifugal equipments, generator, AC generator. So like this, you can find out compressors, pumps, diesel motors, all turbines, etc. through this legend. You have to select the legend accordingly. And these legends are normally fed in the, if you go, normally we prepare the P&ID manually also or through the AutoCAD. See, in AutoCAD, all the legends are there. Just you have to type the name, so you will find the legend. You have to put it on your required location in the P&ID. So normally nowadays, AutoCAD is the best tool for preparing the P&ID because it's a very faster also, very neat and clean, and we can review and redesign as and when it is required. So all the legends normally we can either available or we can feed as per our company guideline also. So next thing is after equipment, normally piping is also important part. So you can find how it is explained here how we can give the specification of piping. So it's one of the classical example. So a pipe is a tube that transports fluid substance. We know that piping can be made of various materials, including metal and plastic, of course. So in P&ID line code example can be like this, but a company can change according to their requirements. You will see there is a code. So if you start from the left, sorry, start from the right. So right first S5, that is specification of piping. 1S5. So it's a basically we can say specifications like MOC. Uh, Through the specification, we can give the MOC. Even few companies in the specification give the details of hot and cold conditions, insulation also. So 1S5 is a specification of the piping. Then line pipe number. So here it is 45455. So through this number you can list out all your piping. So you will have the details of all your piping in your plant. So number is second one from right. Third from right is fluid, GI. So fluid can be like methanol, toluene. All you can company can develop their own terminologies, legends for defining the fluid code of any like water, steam, anything can. Then size. So 2 means 2 inch. Normally size is represented in inch everywhere throughout the world. If anything other than inch, then they specifically mention either it's mm, cm, or otherwise in general normally we use inch as a unit for pipe specification. So here 2 inch means 2 inch internal diameter. Otherwise specifically other mentioned that it's OD. So we have to just keep in mind the 2 inch internal diameter of that piping. So by this way we can share the piping details or we can represent piping in the P&ID. So here you can see that there is a one motor operated, MOV means motor operated valve, uh, then flow transmitter. In between a specification of piping is given. So this way we can share the specification of piping in P&ID. Next slide please. It's a very normally P&ID is very clearly defined available information for all the processes. So now after that there are different legends for different types of piping. So you can say major connected piping is dark, minor connected piping is slight normal, for major straight line, then process connectivity through arrow, feature line, battery limits. So normally battery limits is normally we have to define the battery limits because this is whenever we define any process. So what is downstream maximum limit for this particular project or particular pipe process, and maximum upstream limit. So upstream is starting point, downstream is end point. So we have to define the end point, starting and end point. This uh, starting and end both the points. So that battery limits we can define through this dotted line. That depends upon company to company. It is not a standard. Company can change as per their requirement. So but they have to mention that thing in the legend. So through these legends they can define all the things. Eight trace by edge, side by side, top bottom, one trace line, multi lines, all these we can use. Other signals you can see the sonic signals, nuclear, pneumatic, electrical signals, double connection, flange, end caps too. So different legends are used. If you go to last line, so different legends are there also. So this way piping we can define, so all the different legends, different connections. In general we can say piping means the connection. The different connections we can define through these legends. But again, there is not you standard means in the sense you company can change their terminology or legends as per their requirement. But in general, this is a universally practiced legends. Next slide, please. Yes, piping. So line continuations between different drawings are shown as below. So continuation to or from next sheet. So suppose say we have the limitations of sheets also. So uh, we can use A4, A3, A2, any size of sheets. But again, we have the limitations because like in petrochemical process, it's a very big process. And you'll be surprised to know that in refineries normally we have 1500 to 2000 P&ID, that is of maximum A0 size. So there, when we have to connect one P&ID with other P&ID, so normally we represent to these things. So continuation to from the next sheet. So here continuation, if it's incoming, so you can see top legends. So there we mention the incoming from P&ID number or from equipment also. So this way we can give the continuation. Similarly, if it's outgoing, so sorry, for top one is for outgoing, so to next P&ID. Second one is from it's incoming. So we can say like that. We can show the continuation. So continuation from other than next sheets like that. So origin destination. If you see the right diagrams, legends, so origin destination say to RS420. So it is going to RS420. BI, so again it's a definition of P&ID, description of P&ID number. So same way we can show connected previous P&ID or next P&ID. So this is where we can show the continuation. Similarly, this can be shown in the continuation in the process also. So we can use these legends for showing the continuations or marking the continuations. Next slide, please. Of course, we use different vessels. So there are legends for the vessels also. So vessels is a container that is used to store fluid. So we can see different containers like uh, bottle containers, uh, different chemical containers. Some are stationary, some are mobile also. So it may also alter the characteristic of fluid during storage. So the vessel category includes tanks, cylinders, columns, bags, and other vessels. So few examples are given here. Ayush, please zoom in. So you can see the examples vessel P&ID symbol. So vertical vessel, then open tank, covered tank, tank or storage tank. Normally the tank which is mentioned here, normally they are flat bottom type tanks. Tray column, gas bottles, bags, bin, dome roof tank, cone roof tank, internal floating roof. So normal internal floating roofs are used in crude oil storage, mainly crude oil storage. Internal floating roof, then double wall tank, onion tank. So these are the different legends for different type of vessels or containers or storage tanks. Next one, please. So other vessels are like reactors, which are very important in chemical process. So you can see different type of reactors. Normally you might have used these legends, or you might have come across these reactors in your I think CRE, chemical reaction engineering. So you can see reactors first. If we start from the left, so vessel with uh, deodorization heater, vessel with limpet coil. Limpet coil means utility facility or coil inside the equipment. So limpet coil, vessel with agitator and jacket. So you can see jacket shown inside and agitator shown inside and jacket surrounding the vessel for utility, for supply of cooling water, chill water, steam, all these things. Next one is vessel with coil and agitator. So it's an internal coil, so limpet. So vessel with limpet coil and agitator. Next one is vessel with jacketed coil agitator. So jacketed again. So it's a dual purpose utility. Inside there is a coil or limpet coil. Outside also jacket. So you can supply to utility depending upon different stage of the process, different requirements, and agitator also. So pack bed vessel is there. So it is pack bed is shown through cross. Then tank. Uh, Please go to right side, Ayush. So fluid catalytic cracking equipment, fluid cooking, hydrofluidization, reformer, fluid catalytic cracking, fluid cooking, tubular reactor, fluidized reactors. Please come down, scroll down, please. So these are the different type of vessels we use. These are not the limit. This is not limited to this one only. We may have many more. Of course, in guideline or standard, you will find lot of different ones. So tank, mixer, mixing reactor, jacketed tank, stirrer, furnace, beans, dome roof tank, cone roof tank, internal floating roof tank. So all through this legend, you can easily identify the equipments also. So almost all the equipment you can see. Next slide, please. You can see that from even if you don't mention the tag also, then also you can find you can identify the equipments normally. In general, through the drawings also you can identify this. Of course, other than vessels and equipments, we have heat transferring equipment. Sometimes we call it an exchanger or cooler. So heat exchangers, which are zoom in please, Ayush. So heat exchangers, which normally we are using, is a device that designs to effectively transfer heat from different areas or mediums. This category includes boiler, condenser, and other heat exchangers. So, yeah. So if you see the legends, so boiler symbol is there, hairpin, then sorry, reboiler. Reboiler is mainly we use in the various equipments, mainly like say for example distillation column. So heat to heat the fluid in the distillation column, we use the reboilers. So condensers are different two legends we normally use. One of that you might have seen in our previous uh, sample P&IDs. So evaporative condensers, cooling towers, heating exchanger, air cooled exchanger, hairpin exchanger, plate and frame heat exchanger, spiral heat exchanger, U-tube heat exchangers, double pipe heat exchangers, shell and tube heat exchangers, single pass, double pass heat exchangers, heaters. So all these are legends for mainly heat exchanger equipments, either reboiler, either condenser. Next one, please. So these are the different type of heat exchangers, many more. So every legends have some specific meaning, so you can go through individually in the this uh, soft copy of the P&ID. If you want soft copy of the P&ID, you can contact me or Ayush also. So we will share. We have the soft copy of these standards, so you can use in your education purpose or in the future careers also. Next ones, please. So now pumps or conveying equipments, we can say. So pump is a device that use suction or pressure to raise, compress or move fluids in and out of the other objects. This section is comprised of both pumps and fans. So uh, pumps also of different type of pumps are there. So AODD pump means air operated diaphragm pump. So cavity pump, centrifugal, different type of centrifugal. There are different legends of this centrifugal pumps. So you can use any of them. One, two, three, four, five. Dosing pump, then gear pump. Normally gear pumps are positive displacement pump, hand pump, horizontal pump. Next, please. So these are the many more symbols for the pumps, legends for the pumps. Then comes to instruments. So instruments, actually in instruments, there are a few basic things you have to understand, because that is, you can say, thumb rules or guidelines for the using the legends for the instruments. So if you see anything in circle, means it's an indicator. Indicator, either indicator can be a mechanical device, or can be a electronic device. So indicator means, if you see anything in circle mentioned inside it, it's an indicator. Like TI means temperature indicator, FI means flow indicator, LI means level indicator. Well, if you come down and you can see that LT65 is mentioned. So something, so LT means level transmitter. Transmitter means it's a electronic device. So for indicator, many companies have their different understanding. So sometimes indicators they use it as a manual also, mechanical device like pressure gauge, temperature gauge, or sometimes for instrumentation, electronic device also. But whenever it's a LT, T means it's a transmitter. A transmitter means transmitter something sense and transmit for controlling actions. So like LT is a level transmitter, LR is a level recorder, LC is a level controller. So now third terminology comes. First indicator, then transmitter and controller. So everything is different. Sometimes you will find controller in different way, like circle, the square surrounded to the circle. So that is also one of the legends normally we are using for controller. So transmitter will indicator will indicate the things local. Normally indicator means local. Either it can be mechanical, it can be electronic. At local means at equipment. But transmitter means something that instrument sense and transmit to either control room or either to some other locations. So that is a transmitter. So similarly, controller means it will sense, transmit, and as per set of actions, try to control the flow or pressure or anything, whichever is the desired property. So that is the basic difference: indicator, transmitter, and controller. So in all the parameters, we can have all these things. So again, if you go to right side, third, I think it's a third row, top IP, it's a transducer, means uh, just part of the pneumatic device. Ayush? Ayush? Yeah, thank you. So pressure indicating controller, so PIC, you can see PIC. So pressure indicator is also there and controller is there. So it means local device is also there. So indications and its control action is also there. So control action means sensing, transmitting, and further analyzing for control action. Say for example, we want to maintain a temperature of 50 degree in process, and we are using steam for maintaining the temperature. So this PIC action will be like this, that it will just sense through the sensor, then transmit to the controlling unit. Suppose there is a temperature of 48 degree. We want to maintain 50 degree. So it will sense 48, transmit to controlling device, their analysis will take place, and since we need more temperature, so it will give command to the control valve which is controlling the steam flow to open the valve. So like that PIC will act. So it's a basic difference between the all instrumentation. I'm just trying to explain from P&ID point of view that these are the difference between various instruments, just for your easy understanding. So alarm again is a one more thing. Alarm LA means this will sense and give initiation hooter. That suppose we want to maintain a temperature 50, and suppose our high limit is 55 degree centigrade. So whenever sensor will sense a 55 degree temperature in process, so it will sense and give transmit the signals to alarm section, and their initiator or hooter will activate. So in this way this will work. So LA is for alarm. So different like flow element, temperature element. So element means which is sensing the parameter or detecting the value of the parameters, like for temperature transmitter. Temperature element will be in the reactor. Suppose it is sensing the temperature of reactor, so it will be in the reactor. That element will sense, then it will transmit, and then control, analyzing, controlling action. So like that whole things works, and this way we can represent in the P&ID. Next one, please. So different instruments, you can find many in standards. Next one, please. So again, instruments, discrete instruments like field mounted, as I explained earlier one, it's a field mounted, so field only showing the readings in the fields only. So only circle, main control panel front mounted, main control panel rear mounted, auxiliary control panel front mounted, yeah, auxiliary control panel rear mounted. So this shared instrumentations mean like controlling also there. So these are like this. Control action or some other sharing is there. Computer functions can be designed in can be defined in hexagonal shape. Logics normally we define through a square, but not normally we make a square like this. What is shown in this here? So all the logic means actions. Whenever our element will send something, if only indicate, so there is no action. So action can be alarm, action can be filter control actions, like we want to control a flow. So action can be transmitted to the control valve. So any action that is through logics. So logics can be defined in this manner. These are the general we use all over the world for instrumentation. Within this legends, company defines their own requirement, but these are the general legends for all instruments. Next one, please. So instrument is a very key role in where automatic systems, auto controls are there in the process. Normally, if you might you can recall your earlier readings, also your books or your papers or your subjects. So normally process either continuous or batch. There are two types, and in both process, either it's a manual process, so manually operated, or semi automatic or fully automatic process. So both batch and continuous operations both can be either manual, either semi automated or fully automated. So fully automated, this instrumentation plays a very key role in piping and instrumentation diagram. So this is again explanation of single example of the instrumentation logics. So here you can see it's a E101 equipment. So it's a heat transferring equipment. From symbols you can find it out that it's a heat transfer equipment. So E101. So if we start from normally P&ID, when we start reading the P&ID, we should start from the left. Always it's a basic rule. Normally we should start with the left. Before that you can see the what are important informations where it is mentioned. Or if you just walk around, just review around the boundaries of the P&IDs, you will find the important information. But whenever we start reading the P&ID, we should start from the left. So when we start from the left, so you can find it here, one pump P101. It's a centrifugal pump by legend. So in the pump itself, you can find one M, circle and M. And again HS101. So there is a one motor and one logic is given HS101. Description of this logic you will find in cause and effect diagram. So normally we call it as a cause and effect diagram. Some company may call it the interlocks and logic diagram. So description of HS101 you can find it through cause and effect diagram, but dotted line means it's a logic. Some logic is there, right? So after pump you can find FT101. So FT it's a flow transmitter. Then you will find another dotted line connected to FT is FIC 101. So it's a flow indication and control. Indicator and control FIC. So from FIC you will find a dotted line again to FV101. So FV is a flow valve. So you can see flow valve connected to one FCV101 through blue line. So it's a this legend is for pneumatic connection. So air connection is there. FCV 101 is a flow control valve 101. FV flow valve 101 FIC. So if you just see here, so pump, then control valve FCV 101, then it is going to heat exchanger HE 101. So we can say that flow that is controlled, it's a controlled flow after pump discharge to heat exchanger. So this is the just explanation. Similarly, if you just go to E101, starting from left, there is a PT100, then PI. So PT is a pressure transmitter. PI is some alarm or logic is there. So that is given, that you can again find in the cause and effect diagram. Moving to right, there is a TCV, temperature control valve 102. So this temperature control valve, if you move again top, move about to TCV 102, there is a HV 102 again valve. When we read the various logics mentioned, so if we start with TCV 102, so pneumatic signal is there. So it's a pneumatic line connected to TV 102 and TIRC. So TIRC temperature indicator remote control. RC is the remote control connected to TT. So temperature TT102 is a temperature transmitter which senses the temperature, and based on the set point gives the actions to the TCB102. So suppose we want to maintain a temperature of 50 degree, and so temperature is lesser, so TCB will open based on the sensing. Then sensing will be from TT102 going to TIRC, where action will be defined and action will be command will be given to TCB102 to open the valve or close the valve. This way this control logics works. So similarly, if you see TIRC 102, which is again connected with dotted line to TAH 100 and TAL 100. So this means that TAH means temperature alarm high. So high set point is also normally we mention it through cause and effect we can find it. TAL means temperature alarm low. So for this particular controller, high and low values are also defined. So based on that, this will operate. So in case of high value, alarm will come and actions also side by side will be taken place. So again, if you'll go above HV102, again above that TT103, again temperature transmitter, again above that PT103, before that there is a flow transmitter. So like that, complete informations can be shared, all the controls, logics, everything through this P&ID diagram. So now you can feel that what is the importance of P&ID in any process description. So this is only single one equipment and control actions of that equipment. So suppose you uh, review the process description or details of the refinery. So there are 1600 diagrams. So in every diagram you will find 20, 25, 30 these type of logics. So you can see the importance and value of all these legends. Next slide, please. So again, valves. There are this is mainly pneumatic control valves. So you can find gate valves, globe valves. Of course, I think yeah, it's a manual and instrumentation. Both type of valves are mentioned here. Gate valve, different type of gate valves, globe valves, angle valves, ball valves, pressure safety valves, diaphragm valves. Many more you will find in the standards. Next slide, please. So in the valves, you will also find the end connections or symbols of that also in the P&ID. So these are the different types of valves. The valves also you will find normally it's a one-way valve. So sometimes you will find a two-way valve, three-way valve, four-way valves also that can be described in the P&IDs. Next one, please. So yeah, so how to read P&ID? Most of the component wise or patch wise, I have already explained you how to read the P&ID. Let us see one detailed P&ID before closing these activities. So we can say it's a summarization of complete presentation since the beginning. So please go to next slide. So there is one sample P&ID, you will see it. So starting with, let us start with the surrounding informations like capacity. Start with the capacity, go there, zoom in it, so we can explain it. So normally again when we start reading, we should start from the left, so left top. So Aish, please go to left top, left top first. I think start from right, better. So just go to right and bottom, so that gives the detail of the P&ID diagram. what what is this P&ID, for which purpose this P&ID is there. So yeah, we should start. So zoom in please. So you will find this block in the right bottom in all the P&IDs. So that start with the title of P&ID. So this P&ID is piping and instrumentation diagram. So number 06, synthesis section, thiourea, DFN plant, D, diethane thiol. So it's basically give the description. First title means description of the P&ID. Then if you just see left side, so drawn means who has drawn this P&ID, who has checked this one, who has approved this one. So name and then date. So you will find drawn by VP 11th May 2015, then checked on 11th May and approved on 11th May. Then again moving right, project number. So normally every company gives their project number. It may be a new project, maybe some modifications, but as per their definition they give the project numbers. So through that, this is mainly useful for costing and bifurcations of the drawings. Then drawing number. So drawing number is 1048, so it's a serial number. PID means piping and instrumentation diagram. If it's a PFD, so process flow diagram, block flow diagrams, like that they mention it. So PID is piping and instrumentation diagram. 706 may be a section number, 706, and 4 number is a drawing number of that particular section. So there might be 3 more drawings before this. So 1, 2, 3, and this one is the 4th drawing for that particular section. Again, if you go again to the right, so the sheet number 2 of 3. For this particular section, this particular drawing, there might be 3, 4 drawings. So here, as per this, it's a 3 drawings. So this is second of 3 drawings, 3 sheets. And reviews, RAV is a revision number, the revision number of the drawing, because during the preparation of drawing, first normally that instrument person who is preparing the drawing, he prepares the drawing, then review. After that review, there might be some comments. Then after finalizing the drawing, whole team review the drawing. So then again might be some comments. So every time they give the revision number, so that to track the comments and everything. So first thing we should read these things just to know about the P&ID. Then go up straight. Ayush, please go to straight up. So you will find some notes in the P&IDs. Normally, either in the top, in the middle, but in this section, normally company gives the notes. So like notes, all dimensions are in mm. Existing equipment to be used for the equipment with tag number, prefix, all these minimum notes, whatever is there, what is important, we give it through this note section. Now please go to left top, Ayush. Left top. So here in the top you will find R7404. So it's a tag number. R means it's normally used for reactor. So reactor 7404. This is xylene recovery reactor, capacity 5 KL and MOC. These are the basic minimum information you will find for all the equipment. So it's a tag number, purpose, capacity and MOC. So in the top you will find the details for primary condenser, then CS7404, that's a condenser. Then T, it's a tank. So first you have to see these things. Now come down bottom. Ayush, please go to the bottom. You will find some information in bottom also. So we should also review that. What are the informations available in the P&ID? So again same thing, capacity P7404, it's a pump, xylene transfer pump, capacity 5 meter cube per hour, head. So pump normally we define through head. So 30 mlc motor, of course information is pending, that is why XX is there, but they have to mention it later on. MOC SS316. So these are the basic information you will find in extreme top, extreme bottom and right side. So now please go to left side top, Ayush. Normally we have to start reading P&ID from the top left side. So we are starting normally with the top and we can come down bottom. So if you see in the top left side, so written is that from LPS. So LPS means if you will go to legend, you will find that low pressure steam. So low pressure steam P&ID number is also mentioned 706-1 of 3. So again section, then uh, description 1 of 3, 1, 2 of 3. So 3 P&ID is for LPS. So from LPS this stream is coming. If you go slowly to the right, so low pressure steam is mentioned. I please track this. Low, just mark your pointer. Low pressure steam. Then there is a note 14. So you can go to note 14 now. So Ayush, please go to note 14. What is note 14? In the note 14, you will find for detailed distribution, of utility referred below mentioned P&ID. So medium pressure steam, condense and condensate, low pressure steam and condensate. We have to refer low pressure steam and condensate. So P&ID number 8051 of 1. But if you go, please go to left side. So actual low pressure steam P&ID is 805. But if you just see this P&ID low pressure steam coming from, just go to left, coming from 706. So this might be a process P&ID. From 805, steam is coming to section 706. And from 706, pipe is again connected to this P&ID. So that is why it is coming from 706, 1 of 3. Again, if you go right, Ayush, low pressure steam, node 14, and this steam is connected to, please go to right. So it is, I think this is again passing to next P&ID, that is to LPS 706, 3 of 3. This is 2 of 3 and then 3 of 3. Like that, you have to read the P&ID, right? So this is the basic thing. I just take any one equipment just to, before closing, let us have the explanation of one equipment. Please go to any equipment. So you can see here reactor. In the reactor 7401, few streams are coming. If you start from top from SF7501, this is 7401 reactor, and we just go to the one stream. Let us take one example of one stream. Rest of the stream you can understand later on. So if you go to slide left, Ayush, slide left, we will take one stream. So we are taking topmost stream. So SF7501. Normally SF is used for sparkler filter. So this is coming from sparkler filter 7501, and P&ID number is 706, sheet 1 of 3. If you will just go right, so there is a term, this legend for pipe. So RM3 706 035 50 D4A. So D4A is a specification, 50 is the size of pipe, 50 mm, 035 is a, I think, line number. Yeah, it's a line number. 706 is a P&ID number or section number. RM3 is a raw material 3. So this line will, I think, going to next equipment. So we will take second one because that is going to 7404 equipment. So second, if you just see left side, second from P7403. I just go to left side. 7403. So from P7403, pump 7403, that stream is coming. P&ID number of that pump is 706, 1 of 3, and that is going to reactor. And again, line number is mentioned, line specification is mentioned. Please scroll down, Ayush. So this is connected to one valve, that is a manual valve, isolation valve, and through valve it is connected to reactor. And on the reactor you can find that left side TE is there, that is a temperature element 7404 for reactor. Then TIT is a transmitter, TIC is a controller which is controlling the XV, that is for the steam. So like that you can just understand the process. So this is the basic of the P&ID. Just I tried to explain everything in 1.5 hour. So I hope you now will be familiar with the P&ID, and if you will review the few P&IDs, you will be able to understand the process also, and you will be able to understand, you can develop your understanding about the P&ID. So this is what I tried to explain through this presentation. We will share the presentation to you also. Recording is also there with this, sir. So I will request her to share the recording to me also. You can share to your students also, and we will upload to our YouTube channel also. You can find the later on there also. Yeah, just I want to share that we have a lot of information regarding this designs and process safety on our YouTube channel. So I will share to sir also. You can subscribe that channel also, so you will get regular informations through our this LinkedIn, Instagram, and Twitter and Facebook. You can find a small short informations about safety, but presentations and audios, videos you can find through the YouTube channel. So I will share that also, and we will share this presentation to you also. In the future also you can find through our channel that will be available to our YouTube channel. So this is all about this P&ID piping and instrumentation diagram. Now, if you have any questions, please let me know.
Thank you so much, sir, for your more informative about this P&ID. Now I am requesting all students for the question and answer session. So, do you have any questions? You can unmute yourself and you can ask question, no problem. There is a question from Palak. It is
Please.
written in the Palak comment box that
Okay.
what exactly does the number below pressure indicating controller and other indicator and
Ayush,
transmitters?
Ayush, please go to chat box.
Chat box it is given.
Yeah. What exactly does the number below pressure indicating controller and other indicators and transmitters? So that number is normally logic number. So that logic number you will find in cause and effect diagram or your interlocks and logics list. So from that you can refer that one. Here it is not mentioned, but in one of the our presentation it was there. So that is an interlock and logic number. So directly you can find. You don't have to search there. Okay. Second question is any specific example how P&ID will be helpful in troubleshooting? Yeah, of course. Say, suppose there is a quality problem. So you are not getting the quality. So basically you have to see P&ID, your material balance and energy balance. So for understanding the process, what was designed, actually P&ID gives the design intentions also. So what was designed that we can find it through P&ID. Like suppose there was one example, I can share my personal example. We did a troubleshooting. There was one acephate plant, and acephate in final stage we were using it was a crystallization. Before crystallization, that material was transferred from one equipment to crystallizer, and that actually in normal temperature that material mass was in semi-solid condition. So we were putting steam tracing to that line to maintain a fluid in liquid state to transfer to the crystallizer. So we were trying to find out it was reducing the yield to 4 to 5%, and it was costing around 2 to 300 rupees per kg. So we tried everything, but we could not find the solution. So when we referred the P&ID, suddenly we came to know that their steam tracing was uh, with the trap also, and trap was removed from the actual site. So when we again install the trap, so that because of that trap action of the trap, we could save the loss of that material because of overheating, which was happened because of non-availability of trap. So like that, we can understand each and everything of process, and through that we can do the troubleshooting with the help of material and energy balance. Okay, next one is, sir, for practice, can we start by creating instrumentation diagram for specific equipment, say reactor or distillation or column? Yes, that is a good practice. You take small element. You take pump first. This is a very simple one. Then you go to equipment. Then you go to heat exchanger. So like that, you can add the various equipments one by one, and you can make the P&ID. That is a good thing to start with a very small element. Okay, how do we use the logic numbers? Uh, I think you want to ask how we can give the logic numbers. That is your question. So logic numbers say normally it is based on the flow of the process. Suppose we are starting with a raw material, a storage tank, then pumping a raw material to reactor. So we should start giving logic as per our sequence. Suppose a raw material A is first, we should start with the first raw material A, transferring from storage tank through pump to reactor. If there is an equipment, so that we should give logic number one. Like that, we should go according to process. So that is a best practice. Okay. So I think these are the questions. Any more questions, please?
One more question is that what necessary information is shown on the material balance and energy balance sheet?
Yeah. So basically, first thing is quantity, their purity, uh, specification in general, we can say specification. Then say in energy balance, normally we give the temperature and pressure also along with the flow. In material balance also, it is better to share these things. So these are the basic requirements: specification, temperature and pressure, and some other property specific that also we can mention, like corrosive material, like radioactive material, that also we can mention in the material balance.
Student, any more questions? You can unmute yourself and you can ask directly, no problem. Anyone want to ask question? I think
आई थिंक
there is no
एक बज
question.
गए, भूख लग गई होगी सबको.
Yes, yes. Okay, sir. So let me start the vote of thanks. So really, sir, this lecture is very wonderful and very much informative, especially in our curriculum. We don't study or we don't practice this P&ID until unless we do ourselves. We are not able to do this, and that is very good information. Very much informative lecture. So I feel it is very great honor and privilege to propose the vote of thanks on this memorable occasion of this expert talk. First and foremost, on behalf of University, this Chandigarh University Council, I convey my regards and heartfelt thanks to our honorable guest, Chief Guest Yashpal Singh, Director HSE RMSPL, who despite her busy schedule and found this time for this grace occasion. As well as I am very much thankful to well-wisher, Chancellor, Pro-Chancellor, Dean, Director, HODs. I want to thankful to these distinguished invitees, our student, our faculty members and other faculty members from other department who accepted our invitation. I am also express my heartfelt thanks to our senior professor, Dr. R.C. Katyal sir, who arranged these lectures, who is a visiting professor in this Chandigarh University in the Chemical Engineering Department. We also grateful thanks to our Dr. Navneet ma'am and Dr. Jatinder Kaur, who is supported for this expert. They are the event coordinator. I am also thankful to these members of media and who has arranged given this Microsoft connectivity for this online arrangement. Thank you so much, sir. And again, we will again invite once more for this lecture. Thank you so much, sir.
Thank you, sir. Thank you for patiently hearing me. Thanks a lot.